Okay, so set up the focus correctly. So yes, hello and welcome to my talk, Personal Weather App. My name is Max Maischein and I'm very happy to have you here, or well, wherever here is, to have you in front of your monitor or whatever. I hope you'll enjoy my talk. Is this talk for me? Well, hopefully yes. In this talk, I want to cover several topics. For example, I want to talk a bit about personal privacy, also a bit about application structure, like how can you actually structure an application across different languages, and also a bit about open data, especially weather data, what weather data is available on the internet for your use. I want to show you today two things. One is the available weather data, as I already said, and the second thing is I want to show you a PWA. So yeah, let's get started. My name is Max Maischein. I work for the DZ Bank AG in Frankfurt, the Deutsche Zentralgenossenschaftsbank. This is, I'm a data scientist there, and recently I also acquired the title of digital currency expert. And I'm also a board member of Frankfurt PM, the Frankfurt Perlmongers. We co-organize the German Perl workshop every year, and next year in 2021, we will host the Perl workshop in Leipzig. Hopefully it can happen in person there. If you are interested in coming to the German Perl workshop, look at our website and we will announce it there and also in other venues. Yeah, so I want to talk a bit about weather. I mean, I was for a long time of the opinion that mostly weather is something that happens to other people. But I can stay inside or simply dress accordingly. But yes, there is my godson and his siblings, and they are relatively young kids with age 9 and 6. And so they must go outside every day, and obviously also need to go outside long enough so that they are tired in the evening, and I don't have much don't have to spend much effort in getting them to bed and to sleep. So yeah, the weather forecast has become something of interest to me because I want to dress or want to see that the kids are dressed well enough to stay long enough outside. So yeah, how does a PWA come into play here? Well, PWA obviously stands for Personal Weather Application. Actually, no, it stands for Progressive Web Application, but don't put too much weight on the individual words there because, maybe the web and application are actually of importance, but the word progressive is just there. And what it basically is a website that can dress up as a mobile app. So yeah, that's what a PWA basically is. Now, what do I want from a weather application that displays the weather? Well, I want something like a 3-day forecast for multiple locations and multiple days so that I can know whether the kids can go outside tomorrow or something like that. And for every day, I want something manageable, like 4 forecasts for every day, like morning, midday, evening, and night. And there I'd like the weather in general, like will it be sunny, cloudy, rainy, and the temperature minimum, maximum, something like that. And I'd also like, just for nicer display purposes a today forecast that basically also has the multiple locations, but then simply one big icon with the current weather and again the forecast for today for that location. Something like that. And yeah, of course, there are existing solutions. Let me just check. Yeah, cool. There are existing solutions, but all these existing solutions are really intent on showing me advertisements and also really do want my GPS location. And by really want my GPS location, I mean they want the exact location. That is, I can't geofence it to like something. If the location is within 1 kilometer of this center point, call it work or something, and just return this one location. Yeah, this is thanks to Google, who don't offer any geofencing API. And yeah, I'm somebody, I don't really like to share my location, not with Google, not with anybody. So yeah, those existing solutions are not really what I want. There are also some nice websites like this, for example, https weather.in. It is fairly lightweight, and yeah, it has the drawback of not being available offline. But other than that, it's already in a very minimalistic way, and yeah, quite nice to use from the console, for example. But yeah. Again, the drawback is that it is hosted by other people, so those other people know something about my location, maybe. Of course, there's also the German Weather Service. They have the Warnwetter app, a free application by the government weather service. And yeah, sorry. They also display the weather information and temperature and forecasts the German Weather Service produces. And obviously that data, that application has no advertisements because it's from the government and not from some private company. The data by the German Weather Service is actually free, and there was a bit of a tussle around their app because they also make that app free for download, and the commercial weather suppliers and forecast suppliers were against providing that app in competition to their app. But that got me thinking, because during that tussle, I learned that the German weather data is actually free. So maybe I could just use that weather service data to self-host my own weather display application. So the idea is to fetch the data from the German Weather Service, DWD. That data set is named mosmix multi-output system mix or something like that. They take historical data and enhance that with the current weather data and make then predictions from that. And you get 480 hours of forecast. That's like 20 calendar days of forecast data. And they cover all of Germany and also some other parts of the world where they have weather stations or where they get weather data from. So basically the overall structure will be something like this. We download the data from the German Weather Service using Perl, then store that data in a database and show it on mobile via HTTP. And ideally, we also will make that data available offline on the mobile phone by caching the data aggressively, so that even if even if I don't have a network connection, I can still access the stale data. But stale data is maybe better than having no data at all, at least in this case. So yeah, that's basically what I have, a self-written app. You see here the HTML output of this 3-day forecast. It has some nice emoji for weather display and the temperatures and locations, and also a forecast of today. That these are the two main screens that are of daily interest to me. So let's take a closer look a bit at the applications that I wrote for that, unless there are questions to it. Moderator or chat? No, nothing in chat. Okay. So let's take a look at the structure of the applications. I need to bring the focus back, sorry. So there is a backend which basically concerns itself with fetching the data into my system. And then there is a front end for the console for my desktop written in Perl. It's also some part of the test suite. So I know that I don't break some basic functionality. And obviously for the mobile phone, there is a JavaScript front end that also can fetch the data and display it on the mobile phone. The data that the German Weather Service provides is actually in KML. KML, the Keyhole markup language, is an XML schema for locations. And it's actually a widely used XML schema. At least Google Earth also uses it. And the name Keyhole comes from a series of US spy satellites that also had the name Keyhole. I don't really know what to make of that. So the KML that we get looks a bit like this below in the screen. The German Weather Service added their own namespace for the edition, which is great. They added the DWD forecast tag, and below that the DWD value tag. And within that value tag, there are the forecast values. The only weird thing is that they didn't add or didn't convert their own data to XML, but the payload data within the value tag is actually fixed width data. So we then have to pass that string into a series of numbers, but Perl can do that quite well. So the backend has some tasks. It mainly runs as a cron job that fetches the data from the German Weather Service and passes that data into an SQLite database. And for non-Perl clients, there is a small HTTP server, a CGI script that serves the data over HTTP. And for Perl, there is also a module that provides basically the same API and the database access to the SQLite file, so that I don't have to take the HTTP trip from within Perl. And obviously that Perl API is used in the CGI script to serve the data for other clients. A query and response between a client and the server looks a bit like this. The client asks, I'd like the weather for latitude 50.1 and longitude 8.7, and it gets back an answer. There is the description for the location is Frankfurt Seil, and the center latitude of that location is 50.11, and the longitude is 8.68, and the forecast is cloudy, 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 whatever. So yeah, it gets a pre-digested answer back that should make creating the display for the user a bit easier. The data storage in the backend is fairly simple. It's basically a single SQL table, well, actually two, but I'll get to the second table later. It's basically a 4-column SQL table having the name, which is more or less the ID of the weather station, then the expiry, that is when the forecast expires, and the issue time, which basically is the file where the weather forecast data came from, and then one big string column holding all the forecasts for this location for the next for the next 480 hours in one JSON formatted string. And it's all stored in SQLite. And as I already said, the data is pre-digested because the API will then hand out the same pre-digested data anyway. While importing, I only keep the temperature and weather code forecasts. There are many, many more forecasts like wind speed, dew point at ground level, dew point 2 meters above ground, and some other stuff. I don't have a use for it, so I don't import it into the database, but it's in principle, it can also be imported into the database if there is a need for it. And again, as I already said, the meat of the table is in the forecasts column, stored as JSON. I'm not too unhappy with storing the data in this JSON format because I don't foresee any need to do queries across different weather stations. And even if so, SQLite already has JSON functions, so I could write SQL queries across the JSON column even and extract values from the JSON string for, I don't know, maybe the mean weather across all weather stations in a radius of 10 kilometers around me or something like that. The backend has these jobs: fetch the data, pass the KML data, store it, and make it available as an SQLite database. And the code for this is basically just IOGZip together with XML twig, because IOGZip allows me to read from the KML file without needing to decompress it. So the file stays the 30 megabytes size it is instead of ballooning up to 300 megabyte uncompressed. And XML twig then calls my callbacks where I then pass the fixed width data and extract the temperature and everything that I want from the data. And I promised there would be a second table. The information about the locations and the actual human digestible names are stored in a second table that maps the ID in the name column to a latitude and longitude, and also some description which hopefully gives me an idea while searching for a location, which location I might actually want. Yeah, the data is stored pre-digested. And why do I store the data pre-digested? Because I want to keep my querying logic, or in general, the logic in the front-end programs, very simple. So yeah, let's look again at the API format. It allows, hopefully, I say, for a thin client, because the backend produces the data in a pre-digested way. Basically, the data that the backend delivers is location, and below each location, the forecast. And for each forecast, basically already has the information that I'm going to display already laid out in a grid format. So the forecast has as its first entry the day 1 slot 1 entry, then the day 2 slot 1 entry, and the day 3 slot 1 entry, and after that the day 1 slot 2 entry, and so on. So yeah, there won't be even a need for like parsing rows or anything in the client to know where to wrap the data. This made the template for displaying the data really simple. I chose handlebars as the templating engine because the handlebars template syntax is not entirely horrible. And also there is a handlebars engine for Perl and a handlebars engine for JavaScript. So that more or less means I can reuse the template data, or at least, yeah, I don't have to think in two templating languages depending on whether I'm coding for JavaScript or for Perl. Having the data pre-digested also means that I don't need to write loops in my templating language, because all information is at fixed offsets in the forecasts array. So I just can use the fixed offsets and be done with it. This also made creating the HTML layout much easier for me, because yeah, I don't have to worry about having a variable number of elements in to display. I always know there will be 3x4 elements to display in the temperature. So yeah, that makes it easy to me. Yeah, the structure of the front end programs, the output should be simple between all variants of my front end program. I mean, for the command line client, this is very simple because yeah, it's basically some print statements, and the CGI is also a simple program in terms of logic, because it fills the template from the data and is done. Yeah, but for the JavaScript thing, I want something, yeah, let's call it interactive. I mean, I want to be able to scroll around between the locations, and all of that logic has to be available in JavaScript, because in a likely situation, I won't be online, so I can't fetch new data from the CGI. Now, what does the command line app look like? It looks like this, because on my console, the font I've used does not implement the weather emoji. But yeah, instead you get the output of the HTML version here. It looks, yeah, unsurprising. It has the location and the 3 days with 4 forecast entries for every day. So yeah, no, nothing really fancy there. So basically for the command line and the CGI, the things are clear. We have the application with its data, like which screen to display, the application and its state, like which screen to display and which location list. And we have the weather data, and we put that into the template, and out comes the screen that we display. And for the interactive app, we can fake the interactivity by separating out the state logic again from the weather data, and then instead of updating what we display, we can again re-render the complete page template as long as the JavaScript application has the template included in itself. And yeah, maybe you know this, or if you don't know this, you learn it now. Re-rendering the complete page is bad and confusing, because if the page gets completely rebuilt, you lose the position on the page, and you also lose marked text if you have marked some text using the mouse or something, or if you entered text into a text entry field or something like that. So I really want to avoid re-rendering. And the solution, as with many solutions, is to add one more layer of indirection. So instead of updating and instead of doing the updates by re-rendering the complete page, I re-render the page, diff the page with the current page, and then replace only those parts of the displayed page that are actually different in the new template or in the new rendered page from the old rendered page. So all parts that did not change are simply kept as is. So if the user has marked or changed something that was not changed by the template, it will stay as is. So for JavaScript, the logic looks like this. Instead of simply filling the template and displaying the filled out template, we fill the template, compare that filled out version with the currently displayed page, and then change the currently displayed page or the elements of the currently displayed page to match the new page, and that's it. So yeah, the implementation on the JavaScript side. Oh, sorry, I need to do a quick change. So the implementation on the JavaScript side of the world is basically just vanilla JS and some libraries, like local storage is what I use for storing the data. There is the local forage JS library, and for templating, I already said there is the handlebars JS library, and the page updates that differing between an HTML string and the currently displayed page is done by the morph DOM.js JavaScript library. So yeah, that's the basic overview of the 3 or 2 applications that I showed. There is a bit more about a PWA than just a website that can dress up as a mobile app, because because a PWA can also put an icon on the start screen and also hide the browser address bar. It can store more local data than a simple web page can do, and it can even display notifications on your mobile phone or in the browser. For example, the Zoom app of this, the Zoom website of this browser, this conference, or the Slack website for this conference also could display train notifications on your operating system. And ideally, in the near future, a PWA even can do background data refresh so that my weather app could fetch the weather data in the background instead of only fetching it or trying to fetch it when I open the data, the application. Yeah, so a PWA can be a bit more than just a heavily cached website. So now I'm going to try a live demo. Let's find my console window. There we are. And launch my mobile phone. And I also have to switch over to the new app. There you see it on the phone. I hope you all can see my mobile phone now. So like this. And of course, the application is already live. Here it is. It's basically just what you saw in the screenshots already. You can switch here between the locations, and we see it's nice and warm here. Then we can switch to the current weather, and we also have an about screen and a config screen. Yeah, the font here could be a bit larger, but I'm not a really good HTML wizard. And what is different here between a normal website and a PWA is this little house icon here, which means that this website can be installed on the phone as an app. And if I click this, my browser asks me whether I really want to install this. I say yes, and then I can choose the icon and add it to my start screen. And then if I start it, well, it opens the same app, but there is no more address bar here. And that's the important part of the PWA that nobody needs to know, that it is really just some HTML with a bit of JavaScript. And the most important part is, of course, if I go offline, then I can still use the data, the application, and it still launches, and I still can use it just as if I were online. There is no weather in the cloud. But so everything also works offline just like I want. So let me switch back to the presentation. So I wrote this using vanilla JS. That is, I did not use React or Angular or any of the other frameworks like Vue. Sorry, I forgot that one. But basically put the application together for by using some JavaScript libraries. This has some disadvantages, like there is no support for work by other people. I don't get any fancy pre-made selector widgets or integration with, say, Google Maps or anything. If I want something like that, I will have to write it myself instead of using other people's work. And I also don't get automatic evolution to the latest and greatest browser features because, again, other people who implement this, they might share their code, but if it's not in one of the libraries I already use, I have to do my own development. But it also has big advantages, in my opinion. It's a really small code base. It's 3 JavaScript files, and the additional libraries are like 70K uncompressed code. So yeah, it's manageable code. And also, there is no automatic evolution of things. If I want to put out a new release, I don't download half of the internet from using my build tool and then have to fix all the changed APIs and stuff like that. So yeah, in my opinion, that's still a win. With Germany, I'm quite lucky to have a government weather service that provides free weather data. In other countries, the situation is not too dissimilar, but different. In the US, which is what I will be looking mainly at, there is only an anonymous API available for weather data, not a complete download of forecast data. So that means that your location data is known to the weather service if they want to track you. And if you want weather more international than just Germany and the USA, there is the Weather Underground. They also have an API for worldwide weather data, but you need to request an API key. So yeah, that makes your location much more trackable even than the anonymous location data. For other countries, I've looked at Italy, and then I stopped looking and started implementing, and they don't have free weather data. But if you are aware of other weather services that are free, as in gratis, and also in free to reuse, yeah, I'm always interested in hearing about other weather services. Yes, the code is already online. There's the module Weather Mosmix, which basically implements the backend. And the JavaScript frontend is also online, but not yet on CPAN. It's on GitHub. The link is here in the slide, https://github.com/corion/pwa-weather client. Yeah, I plan to release the weather client onto CPAN as well. What things are still missing from the weather app? I'd like to fetch and display an image of the closest location from Wikimedia maybe. And what I'd really like for the desktop is to configure location data and geofences. So yeah, for several locations, so my notebook can fetch the weather data for my current location, even if it doesn't know actually where it is. But yeah, I don't know of any config file format or something where one could define that. And yeah, one more cosmetic thing is I'd like to replace the emoji by SVG images because the emoji don't always render that nicely, and SVG images would be nicer, I think. And yes, that's it. Thank you. And yes, if there are questions, you can ask them right now or just mail me at corion@corion.net. The slides and the app are online at these links, so you can use the app right from there, but that means I will learn about your locations. So maybe it is smarter to self-host that thing yourself. Okay, thank you.
Thank you very much, Max. Does anybody have any questions? You should be able to unmute yourself.
Seems like there are no questions.
Why do you use PSGI, not a plain CGI?
Because I think I wrote the app in Modrolicious, and yeah, it's just the extension. I don't use a special web server or anything. It's just the file extension, and it is basically a PSGI file because it returns the subroutine, not a CGI thing, I think. Yeah. But there are no architectural choices or anything. It's just, yeah.
Okay, thank you.
There is one more thing. Okay, if there are no more questions, or if you want to ask them later, just mail me or hit me up in the Slack chat. And thank you again for joining me for my talk. Goodbye.
Thanks a lot, Max.